Good morning. Thank you for all the shiny faces that arrived today, 9 a.m. We barely made it. For reasons not involving drinking. I don't know if you heard about there's an elevator incident, but
we survived.
We survived.
It's
It occurred to me now we should have hashtag Chicago Roboto stuck in the elevator, because then we could. But anyway, we are very, very happy for many reasons to be here with you this morning. I'm Huyen Tue dao. I am an Android developer on the Trello app.
And I'm Christina. I'm an Android developer at Pinterest.
And so this is the third part of our series, The Road to Kotlintown. I like to think of this version as The Road to Kotlintown, the abstractioning, but really, I just sprung this on her like last night.
I didn't know.
But really, it's called Coroutine 66 to Delegate 95. So when I know that when I personally talk to people about Kotlin, it is really easy to talk about, and I've used this phrase way too much in the last year, syntactic sugar, and the very forward-facing kind of cool things about Kotlin. But it's not just that Kotlin helps us write cleaner, concise code, but it also helps us build better abstractions, to build more fluent, easily understandable constructs with all of the complexity abstracted away. So today we're going to talk about a few of those things that help you do that in Kotlin. So I'm going to start off, and I'm going to talk about delegation. Delegation is hopefully something that you've heard of before, and basically it's the idea that an object presents an interface. An object has a job to do, and rather than doing it itself, that object passes it back to another object, has a helper object where it delegates the implementation of some interface, some behavior to that object. And there's a lot of reasons why this is a good thing. You probably have heard a billion times over your career as a developer about composition over inheritance and why that's good. So Kotlin actually has several different kinds of delegation. The one that I want to focus on today is delegated properties. So if you have used Kotlin and you adore the property syntax like I do, you know that instead of having to write getters and setters yourself, you can specify a property with var and val, and Kotlin will generate a getter and setter for you. But if you're a very endeavoring kind of person and you want to use delegated properties, what you're saying is that, no, I don't need those generated getters and setters. I'm going to create an object, a delegate, to which I will defer this get and set logic. And at the same time, people that use your object get to have that really sexy property syntax still. So what does this look like? So I have a really, really, really silly example. So delegates start with some kind of delegate object. In this case, I have a class, silly name delegate, and I have my getter and my setter. So these are the methods to which I will delegate the getting and setting of this value. So my setter down here is pretty straightforward. I have kind of my own backing field that I'm kind of managing called actual name. And in my setter, I kind of do something very straightforward. I set that actual name with the input that comes in. Now my getter is a little more interesting and a heck of a lot sillier. So I will check if that actual name is not null. If I do, I return it. If it is null, then I'm going to grab some random name from this really weird list of random names that I have and return that instead. And basically, with this delegate, if I want to use it in a class, I have my silly user with their silly name, and the way that you actually delegate the property is through this syntax. So you start it with val or var, depending on whether you want to read write or a read-only property, and you have this by keyword. And the by keyword is basically saying, okay, delegate this property to this thing, and the thing that follows the by is going to be some instance of a delegate. So in this case, I'm instantiating it right there, my silly name delegate, and that's it. That is how I kind of pass the buck to that delegate object. And here where I'm using the object, you can see that I kind of can just call, that name property, and it does its thing. The name is null at first, so you kind of get some random names coming out, but once we set it to the less silly name of Jerry, Jerry kind of sticks around. So that is how property delegation works. Now that's a really silly example. All I really did was add some custom logic to the getter, and you might say to yourself, well, why don't I just write a custom getter? And that's a really good point. And that is something that you need to think about. But there's other things that property delegation is really good for. Code reuse. And so property delegates are really, really good at when you're doing something in your getters repetitively to kind of reuse that code and to kind of get rid of some of that repetition in your getters and setters. So say I have something like this. So pretend I have some class out there that's managing some page data. And at different points, maybe I want to change the data source, or maybe I want to change the page size. but I want to, obviously refetch that data. And maybe I don't want to fetch it right away, but I have some flag that says, hey, the data's dirty, kind of do a refetch for me. I might do something like this. So I have my two properties, say page size, how many items I want to retrieve on each page, and maybe I have some source, some data URL that I'm grabbing it from. And straightforward, so in each one, I take in the value, I set it to the backing field, and then I set my need fetch flag. This is totally fine. But as you can see, if I had like more parameters, it would kind of start getting really, really repetitive. And I can fix that through property delegation. Now, before I actually get into the kind of specifics of it, let's talk about another example that's a little bit closer maybe to our Android hearts. So a lot of times when we're writing getters and setters, maybe instead of wanting a traditional just plain old backing field, we want to use something else to kind of like store and retrieve the values. So something we love a lot in Android is shared preferences. So we are able to kind of persist certain values across application runs. And maybe say you're dealing with user settings. And rather than always kind of going directly to the shared preferences, you have some kind of object that's like a facade that kind of manages that for you. And maybe you'll do something like this. All right, so I have my user settings. I've got dark mode, because everyone always likes dark mode unless you're presenting on a screen like this where it wouldn't quite work out. And maybe sometimes you want to switch to military time. So I have this as two user settings. And in this case, I'm going to have custom setters and custom getters that rather than saving it to a backing field, I'm saving it to shared preferences. And this is totally fine. It works. But again, it's kind of repetitive, right? I'm kind of basically doing almost the exact same thing in each of these getters and setters for these different properties. And yeah, like two user settings is fine, but I want my user to have as many settings as I want. So maybe I have 8 or 10 of these. And so that code's going to get really, really inflated with all of this extra custom code. But with property delegation, we can make that a lot easier. So let's take a look at how we would actually make this as a delegated property. So I have my shared preferences flag delegate. So I'm going to make kind of any kind of Boolean type flag that I want in my user settings as this delegate. And here are the fun parts: the get value and the set value. And that's all I need to actually make this kind of delegate work. So I have my shared preferences flag class. I've got my get value method. And all it really does is get that shared preferences object, get the Boolean related to the property name. And this is what's really cool. You can actually get some data, some metadata, some information about that property, and then kind of use it within the delegate. So here I'm actually cheating a little bit, and rather than having to specify the key itself, I'm saying, hey, I bet you that property name is the key for the shared preferences, so I'm putting it in there to grab the Boolean out of the shared preferences. And similarly for the set value, I'm kind of doing the opposite. I'm opening up that shared preferences editor, and I'm putting in the Boolean. I'm cheating a little bit and assuming the property name is going to be my key, putting in the value, and that's it. And that all happens in my delegate. And so when I'm actually using this in my class for user settings, this is what it looks like. So again, some really, really much more fluent syntax. I've got my var, dark mode, it's a Boolean, and then I have that really nice by keyword that says, hey, instead of you doing this yourself, you're going to go ahead and delegate it to my shared preferences flag. And the same thing with military time setting. And then finally, when I'm actually using this in action, the person using my user settings object has no idea. It just looks like a regular property. But I get to use shared preferences, and this could be great for, say, fragments, where you have, the get argument, where you have to kind of get and put arguments, and kind of other places like that. You can even use a map if you want to back property delegates. So it's really powerful. It kind of opens up properties a little bit for you. So before we actually get to talking about how this works, I want to talk about one of my favorite subjects in Kotlin, and that's Kotlin conventions. So in Kotlin, you get access to certain language constructs if you basically say the right magic word, which is really just if you implement a function with a certain name. So if you think about Java land, so if you think about having an object as an iterable, and you get to use that really nice for loop syntax, or if you think about try with resources, if you have an auto closable, you can now get that really nice try with resources block where it handles a lot of the kind of closing and cleaning up for you. That is kind of like the same idea, but in Java it's tied to certain interfaces, right? In Kotlin, you get a very similar thing where you can access cool language constructs, but you don't actually have to implement an interface. You just have to name things the right way and add a couple keywords on them. And that is how actually property delegates work. So, and here's just some quick examples of conventions. I think it's a really cool idea, right? That we're not dependent on having a certain type or a certain interface. The compiler is smart enough to say, hey, I see you're using this function name and you kind of have it set up this way, so let me give you this cool thing. And so if you're interested in this at all and you're interested, say, operator overloading, they're done with conventions. There's a lot of other things in Kotlin that are done with conventions, but let's go back to delegates. So to kind of write our own delegate, let's take a really, really simple example and see how conventions and see how these delegates work. So I have a really simple delegate class, and I have a really simple get value and a really simple set value. So again, these are going to be the methods that do the work of the getting and the setting. And so this is what it actually looks like. Here are the conventions. This is what it looks like. So if you want to make your own delegate class and you don't want to have to implement an interface to do it, here's how you do it. So what are the kind of the rules of the convention? So you need the property owner as a parameter to each method. So that's this ref and this ref. Sorry. So that is basically the owner of the property, the class in which that delegated property lives. And the type can be any. Usually for whatever like class that property, that delegated property is going to live, you want it to be of that type or some super type of that. So say like, so I have a class here called Garignac, kind of an odd name for a class, but we're going to go with it. And say if I wanted to make this more specific, I can go ahead and, I'm in Vim. And oops.
How did that happen?
How did that happen? It's not like one of us uses Vim, right? So again, so this could be any, this could be Garignac, it could be this interface that it implements, but if I just put a random class in there, you can see that, sorry, this delegate doesn't quite work for that. So you can note that this ref is the property owner, so make sure that it's of the type any or some super type, which I guess any is. So we'll just leave it as any. So the next part of the convention for both of these is the property. So I kind of mentioned it a little bit at first, but property is this object kproperty, and kproperty lives in kind of like the Kotlin reflection API. And I already mentioned this before, but it gives you information about that property declaration. So it'll be things like the property name, the property type, kind of some other things, which it's a pretty deep well. It's pretty interesting, but you can actually use that to get information about the property and do some neat stuff with it. So you need that. And you also need some return type or some type for that property. So for get value, you kind of basically want to return the type of your property, whatever it is. For set value, this could be that same type, or it could be a super type, but they do have to not match, but again, like either type and a type or a type and super type. And then something else to note is that if you want to do a read-write value, then you need to implement both get value and set value. But if you need just read only, then you do just get value. So down here I have a val, and it's using this delegate. So if I actually remove this set value, still compiles just fine. If I leave it out and I change this to a var, say, oh no, the delegate is like, no, you didn't do a setter. Please either be a val or implement set value for me. So we'll go ahead and put that back. And then finally, the important part is this operator keyword. It's kind of like a flag letting Kotlin know that, yes, this is going to be kind of something that uses conventions and needs to be turned into a delegate. And if I take it out, you can kind of see that, you need the operator property here, or operator keyword here. So that's basically what you need. It sounds like a lot, and I think one of the challenges that I had getting into delegates is remembering what all the conventions were and why they were there. But it's actually pretty simple. And again, there's no interface here. This is just kind of like a specific kind of dance and like handshake that I have to do to get this delegated property. So let's take a look at what it looks like under the hood. So it seems like there's a lot of magic going on, but if you look at the bytecode, it's really, really straightforward. Kotlin really is just taking care of all the hard work for you, and what comes out in the wash is something like this. So this is the bytecode that gets generated in my delegate, and that's pretty beautiful, right? Everyone can do that okay? It looks good. Okay. So here's my delegate class in bytecode, and as you can see, it looks pretty straightforward. There's some like parameter checking, but really here is just my returning that type. And then here, I didn't actually write anything, but here's where setter logic would go. Okay, other than all the checking of parameters, it's pretty straightforward. You could have written this yourself. And then for the actual object that owns that delegated property, this is what kind of the bytecode for that looks like. So the interesting things are here. So you have here an array of kproperties, and it actually stores some of that like interesting reflection metadata stuff related to kproperty for all your delegated properties. And then here's actually an instance of that delegate, the instance of that object kind of taking over for getter, setter. And then in the actual call to the getter, so whatever property I'm getting, the getter for that calls the delegate, calls get value on, and returns that. So again, kind of like forwarding that getter call to the delegate. So again, it's really totally straightforward. It's code that you could write for yourself, but that you don't have to, that you can leave people using your object with a really nice syntax. So, as I've mentioned, the conventions are great and I love them now, but they were really hard for me to remember when I first started doing delegates. But there are actually some helper interfaces. If you are not comfortable yet letting go of interfaces, there are a couple that can actually help you write delegates. So, they're very straightforwardly named. So the first one is ReadWrite Property. So it's an interface. It takes two parameters, two types. One is going to be that kind of property owner type, and the other is going to be like the actual type of the property. And here I have a delegate. So here I have a read-write delegate from interface. And if I just extend that read-write property and specify, again, the property owner type and the actual property type, I'm going to then override the get value and set value. And as you can see, they have pretty much the exact same signatures as like my kind of convention version of it. A few differences. Since it is like implementing an interface, I have override instead of operator, and that's really pretty much it. The implementations I have here are the same. They're really dumb for the purposes of this example, but as you can see, there's not too much difference. But it does kind of help you if you don't really quite know what everything is and where things should go. You can implement rewrite property, and again, you can get all the nice IntelliJ code completion for you. And here is the kind of other part of that, the read-only property. Again, if you're doing a val, you'll want to implement this interface, and you just have to implement that get value method, and you're good. And then using those two is just like any other delegate that we've looked at so far. Property declaration, by keyword, and then an instance of that delegate. So while you can use these kind of to hold your hand when you're first doing property delegation, you actually probably shouldn't. You probably should just get used to conventions, and I'll show you why. And it's not, it's kind of comes out in the bytecode. So without going into it too much, because that would be like a whole other talk, because of extending this kind of interface that has generics in it, you actually end up generating some extra methods. Like in the bytecode, there's synthetic methods and bridge methods that pop up because of type erasure. Totally other talk. But as you can see, it actually adds some extra code in there. And while this might not be a huge deal at all if you have one or two of these, you can imagine if you start having much more complex interfaces and a lot more properties that, things add up, and it's just something to be aware of. And, I guess your mileage might vary, but, between adding 2 extra methods and all of this kind of extra crops in the bytecode versus actually just doing the conventions, I'll pick the conventions. But again, even if you just want to cheat and look at the interface, that's what I do still all the time to see what the signatures should be, you can do that. So it's really just best to use conventions, and I think JetBrains actually says that. I think in the documentation either for these two interfaces or on the delegation documentation in general, so it's not just me saying that. But you don't have to create your own delegates. Developers are lazy, I know I am, and there are some standard property delegates in the Kotlin standard library that you can use. The first one that you probably have heard of already or seen already is basically the lazy. Which is basically lazy initialization, and that's really handy when you when you prefer to instantiate an object when it's first used. And it's really handy if you say have an object that's really expensive and you might not necessarily be using it, and you want to just go ahead and only instantiate it when you're going to use it. And it might look something like this. Again, that really awesome by keyword that indicates that we're using delegation, and you basically just type in lazy. That lazy takes a lambda, and that lambda is kind of where you do the initialization of your object. And what's really cool, again, is that because it's lazily instantiated, if you have something like this, like in a conditional, if this actually passes, then it short circuits it, and I never have to touch that initialization to begin with. And again, kind of saving yourself some trouble if you have something really expensive and is not often used or not always used. Something to note though about lazy is that lambda, that block, is actually by default synchronized. So there is some performance implications there. Again, your mileage might vary. You might argue with me. We could probably have a debate about it, but it's just something to be aware of and something that might be a non-trivial impact for you. But if you're not really interested in synchronization, there are other thread modes, thread safety modes that you can access just by passing in an extra parameter to lazy. There's publication, which is basically okay, all the threads will race to see who implements it first, and whoever gets there first wins, and then all the other threads get that value, or there's just none. So say you're doing lazy and you know that you're only ever going to do it on one thread, then you just throw none at it and it won't actually be synchronized. So lazy, like some of the other things that I talked about today though, is not free. Again, like it's synchronized, so you have to kind of, if you are really kind of worried about performance, that might be a bottleneck for you. And also because of just some of the generated code and other things, there you might actually end up with some synthetic and bridge methods in the code. Not that it really matters sometimes, but sometimes it might. So, but again, something to be aware of. If you're doing just a few of these things in isolation, no big deal. But if you start having a lot of them, it is something you might have to think about. So, something that I know I did when I first learned about lazy was do this. And what I think is really interesting is like, in Android, we have activities and fragments, right? And we declare the class, we like declare variables for it, but we don't actually instantiate it, which becomes kind of a pain in the butt with Kotlin sometimes, with like val versus var and like nullable types, and what am I going to set this to, but I don't want to set it to anything. And so I know I would do something like this very often, where I would do by lazy and get a drawable through a resource, and that's great and all. But it's not always the best solution, again, because it's not totally for free, and there are other situations where this might not work. So here's something that I know I did and caused a problem my first few months doing Kotlin rather. And so I have here a fragment, and say that I felt like using lazy to actually grab a view from that fragment. What happens when that fragment's view gets destroyed? Well, lazy's only ever initialized once, so now you have this view from this dead, now you have this reference to this dead view that is no longer existing. So you have to be really careful about something like that. When you're using lazy, make sure that it's not something that could actually be destroyed or not exist by the next time you want to use it. So sometimes it's just easier just to initialize your variables, and that's what I've kind of learned. You have to be kind of judicious about this. And I know at work I've had PRs where I'm just where I've done it and someone's been like, hey, it's a little bit, maybe you should just set the variable. It's probably easier that way. And I agree. So it's there for you to use, but definitely kind of be cognizant of when you're using it. So some other standard property delegates, which I really, really like, have helped me kind of solve some really interesting problems at work, and I've totally kind of fallen in love with them lately. So I've written code like this very recently. I did some UI work very recently for work, and I love doing custom view work, but I end up with code like this a lot, where I have some view properties. I have text, I have text size, and so a few things happens, right? So when you set properties on a view, usually you'll want that view to be redrawn and also relayed out. So you'll have a setter, and you'll say, okay, well, I want to also request layout on that view, and I want to invalidate that view so it gets redrawn. That's cool. And also because relayout is kind of expensive, I probably want to throw a check in there to see if the field and the value are actually different, and then I only want to do all that hard work if they are. And so I have code like this. And it's fine, it works, but there's repetition, right? And I don't need to do this 10 times for all 10 properties of my custom view. So how can I fix that? Well, I could use something like delegates.observable. So this is a standard property delegate that's in the Kotlin standard library. And what it basically allows you to do is to create a delegated property. And it actually mostly works like a regular getter setter. There's a backing field. But what it allows you to do is to specify a callback that gets run after that property is changed. So I might have something like this. So maybe I have a border color that I want to make sure that I request layout and invalidate once I change that border color. So here's the syntax. I call, I declare the property like normal. I have might by, and then I specify that instance of a delegate that I want to use to defer that property to. And so so delegates is an object declaration. It's kind of basically a singleton. And then I call observable on it. And then I pass in an initial value. And then I also have a lambda where the parameters of that lambda are the k property, that kind of reflection, metadata information about that property, the previous value, and the new value for that. And then whatever you need to do, you can use those parameters to do. Here, I'm simply going to call request layout and invalidate. And now every time I set that border color, I will automatically say, hey, view, make sure that you relay yourself out and redraw yourself. Cool. I can actually, though, make this even nicer and write a method. So here I have layout property, and I've actually parameterized it so it can take in different types. I'll have one parameter that's an initial value, and then I'll go ahead and actually return a delegate, an observable delegate that goes ahead and calls request layout and invalidate for me, and then I can go ahead and use it directly with my property. So that's really awesome. But there's also another one that I very recently learned about called vetoable. which basically allows you to veto the setting of a value, which is kind of neat. So say, again, like I mentioned, layout and drawing is kind of expensive in Android, so you want to avoid it if nothing really changes. So maybe I have text, and I really don't want to do, if I really don't want to do anything, or I really don't want to do anything, if that text hasn't changed, so maybe I'll use a vetoable. And so, again, I'll call delegates, which is that singleton that has all these nice standard property delegates on it. I pass in an initial value, and I pass in some lambda that is basically a check on whether, should I actually execute this change based on this kind of the evaluation of this lambda, which returns a Boolean. So that's all fine, but again, going back to my example, I wanted to both do something when my kind of setter got set, but I also wanted to kind of check to make sure that I wasn't doing too much work on my view. So again, the standard property delegates are great, but you can kind of take them and mash them together and make something interesting. And I made a vetoable observable. And I did that by actually kind of taking observable property, which is what both vetoable and observable are built on top of. And inside of that is actually two callbacks, before change and after change. And then I just actually override them, and I could do both of those things. I could check, hey, is my new value equal to my old value? Yes or no. If yes, then go ahead and ignore the change, or and then I have my callback for after change where I call request and layout. So so just kind of to wrap up on delegates, kind of the number one rule here is don't abuse delegates. So number one, they are not trivial things. They do have some kind of cost. So you should be, just aware of that. You might not even have to worry about it most of the time, but it is something that you should be aware of. And possible performance impact. And also avoid unreasonable side effects. So as you can see, it's really easy to start putting in a lot of interesting logic in your getters and setters. But don't do something like this where you set a color and you write to the database. It's really easy with delegation to kind of start doing crazy things, but for the sake of your team and your own sanity in 6 months when you have no idea why you did this, try to keep it reasonable, right? So in a custom view, I'm changing properties that I would expect to relay out things and redraw things. It's reasonable to kind of invalidate things. It wouldn't be reasonable to do a network call or a database call. So just kind of keep that in mind. And with that, delegation, again, is about kind of taking complexity and abstracting it away. Now, Christina's going to talk about something that is very related to complexity and abstracting that away, that JetBrains does for us.
Can you Vim me?
Can I Vim you? Yes, I can Vim you.
This is the fun part about sharing a computer.
Yeah, I think it's Vimmed.
All right.
Cool.
All right. So, again, my name is Christina, and as Huyen introduced me, I'm here to talk to you about coroutines. Now, how many people in the room use coroutines? All 5 of you. All right. Yeah, this is great. It's going to be awesome. All right. So because of that, I had suspected that a lot of people have heard coroutines, but they don't know the motivation behind it. They don't know how they work, and it's a little bit scary. So I wanted to take a step back today and give that groundwork, less implementation, more theoretical. So to start, I'm going to give you my hypothesis on code because I have the stage and I get to commandeer your time. So it goes a little something like this. Complexity can be moved and it can be multiplied, but it can't ever be eliminated. So you may say, okay, that sounds great, but are you sure about that? Well, I've given you 3 examples because if I give you 3, I think it proves all cases. So first, say you're really good about coding and you have everything in a single-use container. It does one job and it does it well. Well, in that case, now you have a lot of containers, so congrats, that's really complex. 2, you can say, well, having containers, a lot of them to manage is complex, so why don't I get rid of that responsibility, put it into a library and use someone else's work? And that's great, but now that black box is also complex. And then you can also do our favorite pastime, which is writing really, really terrible spaghetti code that is a nightmare for all your coworkers. And congrats, you've multiplied the complexity. Yay, you've leveled up. But even if you do your best work, you go in and you refactor that and you use every modern paradigm, you cannot get that to complexity level 0. There will still be one of these first 2 cases. Now, hopefully you trust me on this, but you're probably now asking, what does that have to do with coroutines? Well, In my opinion, coroutines move complexity. And I'm going to say that one more time for the people in the back, in the balcony. Coroutines move complexity. And the reason I want to drive home that point is because they're not magic. They're not doing anything that we don't know how to do on our own, but they're doing something that's hard enough that we probably don't want to do it on our own. So us, users, are happy. People who maintain coroutines, something other than happy, probably. But that should probably beg the question of why do they take that responsibility on themselves? Managing coroutines cannot be fun. It's a bunch of threading logic and sharing of threading. And so the answer to that is, as always, threads. And especially the fact that threads are relatively expensive compared to other things we can be doing in our programming lives. Because they're relatively expensive, we can't keep an infinite number of them alive at any given time, which makes them a constrained resource. Anytime you block some sort of constrained resource, you're reducing your throughput. So if you had 10 channels open and now you only have 5, you're going to get less work done. So blocking is bad. What is the solution? Do not block. All right, pretty easy. Well, that brings us to our definition of coroutines. What are coroutines? They are computations that can be suspended without blocking a thread. Okay, seems reasonable. But if you are a wise person in the audience, you may say, how can you suspend without blocking? And the answer is cooperation. I love that you appreciate that, because I love it, so thank you. We're here for it on Friday morning. Okay, so problem recap, that introduction. Threads are relatively expensive, and so we can't keep an infinite number alive. Blocking them is, not great. It can slow down our progress. Ergo, we should make sure we only block if we really need to, and otherwise get out of the way. And also, threads are complicated, so maybe we should get someone else to do that work. Okay, so that brings us to coroutines. Now, the word we use, coroutines, we throw it around a lot, but it actually has 3 major components. One is the language level support. 2 is that low-level support, aka you're writing and maintaining your own coroutines. And 3 is your end-user experience of someone's given me coroutines in some library, I need to consume them and make use of them. So let's dive into that first part. Language support, by and large, looks something like this one word, suspend. And you look at that, and then you look at other functions, and you're like, oh, okay, great, they look exactly the same. You can name them, you can pass in arguments, you can return arguments, so cool, we have this word, what does it do? Well, the fun thing is it means you can't do what you normally do, aka this. In our non-suspending case, we can use that function anywhere. We can put it in that async block, which is a coroutine builder we'll cover later, and it's fine, and we can use it outside of the block, and it's fine. But now that we've added the suspend word, suddenly it's a compilation error. And specifically, the compilation error is saying you can't use this unless you're in another suspended function or if you're in a coroutine. So that seems a little less than ideal. We add this suspend word, and all of a sudden we can't call our function where we want to call it anymore. And so that should beg the question, why? Like, why add this word if it's just going to constrain what we can use our function for? And to understand the answer to that, you need to understand something about how coroutines work and what exactly they do. So let's dive into that low-level piece, also called So You Think You Can Coroutine. Coming to ABC. So anytime you click into any code related to coroutines, this is some snippet I pulled off of GitHub, you'll see something like this, and it probably won't make sense, but if you keep clicking through, more and more often you're going to see this one word. It's going to be everywhere. It's continuation. Now, you may say, okay, so what's a continuation? And the answer is that this is here because coroutines are built on continuation passing. Like that is the theory that underlines coroutines. And so now you're probably like, okay, but what does that actually mean? And we're going to backpedal a little bit to lay the foundation. So you've clicked through, you know that there's this word continuation, but what does that actually do for you? Well, in order to understand what a continuation is, we have to revisit that first piece that we laid down, which is the suspend keyword. And what that's doing is it's indicating to you that this function may at some point suspend or invite suspension. Now, I use that language carefully because there are these 2 side notes. One, that suspend keyword, it's an invitation. It doesn't always have to suspend. And two, you could use a non-suspending function in a coroutine. Why? I don't know, but to each their own. It has a lot of overhead for no discernible benefits, but everybody can code the way they want. So the other thing about that suspend keyword is that when we use it, we're marking suspension explicitly. Like, we are putting a word there. We are saying this is something that can suspend. It is explicit. And this is different as opposed to, like, say, some threading model which can be preemptive. So every 100 milliseconds or something like that, it'll preempt the thread and switch over. For us, we are inviting that suspension. We have to say, hey, here's a point at which you can suspend me. So if we put those two bits of knowledge together, that first, that we have the suspend keyword, which means that coroutines can only be suspended at certain points, we can derive this second piece of information, which is that if there are limited points that we can suspend, that means there is a finite number of states. So finite states. Oh goody, a state machine. Perfect, my favorite topic. Why do we care about state machines? Well, because this is the underpinning of coroutines. This is how they're implemented. This is an approach that's shared by other languages as well who implement coroutines. The reason is predominantly for performance. The really cool detail about implementing as a state machine means that you can have an arbitrary number of suspension points in a coroutine and still generate only one class. Do you need to know about that? No, but maybe you'll win trivia night one day. So, to give you an example, there was this was written in the documentation, but it used like foo and bar and a and b, and it just seemed a little less than fun. So I rewrote it with a story from my life that hopefully you'll enjoy. And it starts like this. I have a dog. This is wishful thinking. I do not have a dog, but I would love one. Two, apparently when you have dogs, you have to take them for walks, and that takes time. Like, say you take your dog for a 15-minute walk. So this is some asynchronous thing. We're going to have to wait for it. Now, animals go to the bathroom on walks usually, so this will return some value. And then once you return home from your walk, maybe you're distracted, watch TV, I don't know, do something else. And then there's this other little known fact about having pets, which is that sometimes they pee in your house. So that's usually a function of your pet and whether they went to the bathroom outside before. If you have not taken them from a walk, there is a very high probability that you're going to have an accident. But you won't know this until the end of the evening because this is a function of time. So you'll like go and sit down for dinner, and then maybe 4 hours later, you're going to be upset, or maybe you won't. So we have this long-running function that returns an upset level, and of course all problems are solved with ice cream. So at the end of the night, if you're happy, you should eat ice cream to celebrate, and if you're sad, you should eat ice cream to console yourself. Either way, win-win. So what does that look like? Well, this again is the same snippet of code from the documentation, but updated. And again, you don't have to read through all of this. I just want to give you the shape of what this state machine, the implementation of it is. So at the top, we have all of these local fields. And then you can see that the meat of this is just that resume function. There are 3 different states that we can take on. The first one is when we create the dog, and then we have to do that long-running walk function. So, woohoo! Hello. So we go ahead and suspend because that's going to take a while. Then we come back, we use our data, then we start another something, so we suspend, and then we come back and we have our final state. So you should see that this looks like a state machine because indeed it is one. So that is awesome. Why do we care? Efficiency, as I said before, but also there's this really cool benefit of all state machines, which is that you can usually serialize and persist them. So if we recap what we know, state machine, and then we have suspension points, and if we can serialize the state, that means we can also serialize and store our coroutines. So how? This is where it all circles back to where we started. What is a continuation? Well, a continuation is a state of a suspended coroutine at a suspension point. Totally clear. And so if that wasn't clear, even though we've kind of done that whole jigamarole, this is what the interface looks like. It's a glorified callback. So we have some context that we attach to it, we have a resume, and we have a resume with exception. This is it. If you click through on continuation in any of your coroutine code, it's going to look like this. This is exactly what it is. So how do you use that? Well, I pulled in from the open source community. This is just an example. It takes a retrofit call and it adapts it to the coroutine world. So the salient points here is that we're launching this coroutine. It is passing a continuation passing style. And what are we doing with it? We're calling resume if we get a result in the onResponse, or we're calling resume with exception if we have an error. Now, there's some code down here for cancellation, and you'll usually have to manage that too, but it really does come down to those two pieces. Of course, I've very conveniently glossed over the fact that there is a coroutine context. And if you go ahead and look at that and click through, what you're going to see is that it just has bits of data. So you can get things, you can fold, you can add, you can subtract, you can have things within things. There's nothing crazy going on there. It's pretty standard. But one thing worth calling out is that something that your coroutines contain is a continuation interceptor. Now, if you look at this, it is a coroutine context element, so it's an element of your context. And the main thing to note is that it has this intercept continuation function on it. Now, why do we care? Well, because threading. You still have to manage threads at the end of the day. And what you can do with coroutines is you can have your dispatcher call that intercept method, and you can override where it's running. So underlying all of your threading models is just this function which dispatches and says, hey, do you have any advice on where I should dispatch? And if you do, it follows your advice, and if you don't, it just goes on its merry way and does what it would have done anyways. So, that was a lot. And now you should be wondering, that sounds awful, why should I actually use this? And there are some concrete benefits to using coroutines. So, right out of the box, JetBrains gives you coroutine builders. This is to make your life easier because I just went through all of the parts that will make it a little bit miserable. So, we have these like little goodies to keep us going. These are some of the ones that come out of the box. They're not very descriptive to look at, so I've added types, and hopefully the types will inform what their use cases are. So here, launch is something that returns a job, which is cancelable. We have deferred, which has that promise-like behavior. It's asynchronous. We have something that's run blocking. We have receive and send channels, like in Go. And so you can go in and explore these things, but the crux of the matter is that they allow you to launch suspending functions without errors. So if you remember earlier in the talk, when we tried to call this suspending function, something like this, it wouldn't compile. When we wrap it in launch, that now has the coroutine wrapped into the coroutine builder, and so you can call it without a compilation issue. So if you want to go in and play with coroutines, learn something about them, you can build something like this. Unfortunately, it won't work, so that's a bummer. And the reason it won't work is that coroutines are very much like daemon threads, which is that they won't keep the process alive if it was otherwise going to die. And so what you have to do is you have to wrap it, if you're doing experimentation like this, in something like run blocking. What that's going to do is it's going to keep the process alive while you do your coroutine so that you can actually get the results that you want. Now, something worth calling out is the fact that coroutines are synchronous within the coroutine context by default. So here, I've done something for 1 second, I've done something for 2 seconds, and when I print out that result, it's going to say that the whole thing took 3 seconds. And that's just because I'm calling these functions with no modifiers. Now, if I want to have that asynchronous behavior, I have to do it explicitly. Asynchronous behavior in coroutines is explicit. And so here you can see that I've added that async keyword. And now when I call this same function, which does something for 1 second and does something for 2 seconds, it returns in 2 seconds. They're running in parallel, and it's going with the longest running process. So, synchronous by default. If you want anything to happen in parallel, you have to be explicit about it. Now, you might say, okay, so that's fun. You've told me how to experiment with these, but what are their use cases in the real world? Well, I'm glad you asked. I'm going to throw Jake under the bus because he's such an easy target, and he has a lot of open source that uses coroutines. So I went into his project and I poked around trying to find a really good example, and one of them that came up was this load method. And so what it does is it takes a bunch of references, and for each of them it launches a load. And what does that load look like? Well, it has this fetch step where we're hitting some service, some URL, and we're trying to get our arguments, we get them back, we do some processing on them, and once we've done that processing, we then want to store them. So you'll notice this looks very much like code you would write. You're not doing any explicit threading here. We have just our like API and then our writes, and everything is written out in sequence. It's not done using the async keyword here. So you can do a lot of things like this. I would encourage you to go into that project and like poke around at it. But You may have a couple moments of doubt before you do, because there's always these topics that come up whenever anybody talks about coroutines. The first is that experimental keyword, which is really fun. And the TLDR on that is that experimental is there so that users don't get screwed over. That's the technical term for it, by the way. So what does that mean? It means that they're still changing some of the ways that these are designed. And if they do that, they can break things downstream. So if you're writing a library and you make these changes, it can hurt your users in the end. So if they keep it in this experimental package, then later on, when they finalize everything, they can move it out of that package, and users can go on seamlessly without having, like, if they want to keep using experimental, they can, or they can upgrade. Now, there's this other thing, which is Rx. The last thing that I'll say, Rx and coroutines, they're not mutually exclusive. And I hope with this like really speedy overview that became apparent. And that's because Rx, like they're this asynchronous streaming library. And coroutines are a way to do a unit of computation without blocking a thread. And those things, they are not on the same level. They are not the same abstraction. They're not addressing the same problem. They do overlap in the solution space, but there's no reason you can't use them together. There's no reason you can't use both, or you can choose one or the other and then force it into whichever problem set you have, but they're not mutually exclusive. So with that, we're getting yanked off stage. We ran a little bit over. Thank you for your attention. And if you want to reach out to us, I'm Christina, and this is Huyen, and this was the workshop.